Hello, my name is PARAN, manager number CE180019. I am from group 4. In this assignment, our group will present our title is Recyclable Material Classification by using the Convolutional Neutral Network CNN. So before that, let me introduce our group member. My group is Nurjan, NAJIHA, BINTI, BAHRIN, and June, NEGRO, ANAK, JANIS. So in the assignment, we will present the introductions, methodology, result and analysis, and conclusion. So the first thing first is about the introduction. So the first is recycling as at most important from economic and environmental aspect because it is vital to maintaining an effective recycling system. So the second as recyclable material classification is a challenging problem. It's requires meticulous technique to obtain a reliable data set. So the convolutional neural network CNN is a class of deep learning neural network, and also the pre-trained model that we had used for this project are CNN, VGG, and denser nets. And third, for this project, we had focused on the ability to distinguish between trace item and recyclable item. So we have two examples of overfitting and underfitting. So the overfitting actually is a good performance on the trained data, poor generalization to other data, and the underfitting is the poor performance on the trained data and poor generalization to other data. So as you can see, we have three output graph. The first is highest height bias underfit, and second is just right, and third is height variance in overfit. So that's all. Thank you.
Hello, my name is JANIS and my matrix number is CE180032. So right now I will proceed to the methodology for this assignment. So as you can see here, we are using four trend data set, or we use these four models to do this assignment. So the first one is the convolutional neural network CNN. The second one is visual geometry group VGG16, and the third one is dense convolutional network DenseNet, and the last one is for deep convolutional neural network LXX. So right now I will proceed to the first one is. So as you can see here, this is the first one. The first one is the convolutional neural network, which is CNN. So we can see that the terms of convolutional refers to the mathematical equations of two functions to produce the third functions. So it merged two sets of informations. In the case of CNN, the convolutional is performed on the input data with the use of filter or kernel. So the most beneficial aspect of CNN is to reducing the number of the parameters in artificial neural network, which is A and N. So right now we will proceed to the second one, which is the visual geometry group VGG16. So the VGG16 is a 16-layer convolutional neural network CNN. There are around 138 million parameters in VGG. In the ImageNet dataset with over 14 million photos divided into 1,000 clusters, the model achieved 92.7% top 15 test accuracy. The need to reduce the parameters in the convolutional layers and improve training time led to the development of VGG. And we continue with the next one, which is the dense convolutional network, which is we call it DenseNet. As you can see here, this is the figure of the DenseNet blocks and transitions layer in DenseNet. We can see that the dense convolutional network DenseNet is a relatively recent development in the field of neural networks for visual object identifications. DenseNet is fairly similar to the ResNet, with a few key distinctions. ResNet employs an additive approach for combining the previous layer identity output with the future layer, whereas DenseNet concatenates the previous layer's output with the future layer. DenseNet was created particularly to address the vanishing gradient effect in high-level neural network. So in plain terms, because of the path between the input and output layers is longer, the information is lost before it reaches the destinations. So the figure shows that the dense net is split into the dense blocks, each of which has distinct set of vectors but same dimensions. The transitions layer utilizes best normalization through downsampling, which is an important step in convolutional neural networks (CNN). And we will proceed to the last one, which is the deep convolutional neural network (LXNet). So what is LXNet? LXNet, which use the add layer CNN. This network demonstrates that learning-based features can outperform manual design features, shattering the previous paradigm in computer vision. LXNet use rectified linear unit, which we call it ReLU, instead of the 10 functions, the traditional way, which was a standard at time. ReLU's advantages is in training time. CNN using ReLU was able to reach 25% errors on CFAR 10 dataset in 6 times faster than CNN faster than CNN, which using the 10 functions. As shown in the figure 2.8 figure here, we can see that this is the architecture of the LXNet. This one is the architecture for the LXNet, and this one is actually for the LeNet, which is kind of similar. So I think that's all from me. Thank you.
Hello, my name is Andrew, and in this part I will presenting how to demonstrate in task 1. So first thing first, we open the Google Colabs. So I already open my Google Colab and connect to my Google Drive. So going to ADA, choose the notebook setting, make sure we use the GPU in notebook setting. So the second step is the feed my dataset directory to Google Drive, and namely is assignments, and give rename the assignment, and step 3 create the manipulation pilot the data. So for example, I have 3 files: test, trying, and validations. And then for the step 4 is we construct the CNN convolutions. So step 5 is the form architecture. In step 5 we use the 3 data input, and going to step 6 is training process. So our training process, as you can see, the step per approach equal 20, average 15, relation data relation generator, and relation step is 10. And for the step 7 is import manipulations. It is the input the outcomes. After we build the command, we try to run this. Okay, after the run is the complete, you can see the result as shown below. You can see the drive is already mounted. Its pad train length is 310, can train length 156, and pad evaluation length is 133, and cannibal length is 77. So next is his whole system. So you can see the training process. The first step is 5 seconds, 4 seconds, and next is 4 seconds, 4 seconds, and last is 3 seconds. And you can see the output graph. It starts from 0 until 14, and also the second is 0, starting from 0 until 14. So that's all from me. Thank you.
Assalamualaikum and good day. My name is NAJIHA binti BAHRIN with matric kat CE180123 for ICS assignment 2. I will present task 2. Okay, in this part, one of the two pre-trained model GG and DenseNet is required to construct a CNN model to perfect the optimum tuning till maximum validation is obtained. The result of this task will compare with the result of task 1. So for this training process, a few parameters have been established to get the result such that each step achieve the greater validation value. Therefore, the parameter sets the step number per approach to be 5, the approach value to be 10, and the validation step value to be 5. At first, this is how I construct pre-trained model with GG using Google Colab. This is the coding, and this is how I construct pre-trained model with DenseNet. Here is the I attach the coding. Okay, this is structure of VGG architecture. We got the layer type, output shape, and param. Okay, so total param we got 414,714,688, and trainable param we got 0, and non-trainable param 414,714,688. Okay, the next part is structure of the DenseNet architecture. Here is the output for structure of DenseNet architecture. Model sequential _1. We got the layer type, output shape, and param. Total param is 18910,017. Trainable param 4,195,329. And trainable param 14714,688. Okay, this is training process. For the training process, this is the coding I attached, and this is the output from approach 1 until approach 10. Okay, this is the graph output, the accuracy and loss. Okay, the graph output show most of training accuracy is 1.0 and the higher value validation accuracy is 1.0. So I'm gonna show you for the task 2 ICS assignment 2. Okay, this is how I run my task 2 by using Google Colab. At first step, we need to connect to Google Drive, and this is the coding. And for second step is dataset directory, and this is I import OS. The coding I import the dataset directory. And for step 3, this is the train and validation data directory. This is the coding. And then for number 4, we construct pre-trained model with VGG. So we construct, how we construct is we start with by the coding conv_base equal to tf.keras.application.vgg16 weight equal to imagnet include _top equal to false, and input _shape where 150,150,3, and then we print, and we move to the step number 5, construct pre-trained model with DenseNet. This is the code for how we construct pre-trained model with DenseNet. And then for step 6, pre-processing the input data. Okay, this is the coding. And then the output we got is found 466 images belonging to 2 classes, and then 210 images belonging to 2 classes, database shape 20, 150, 150.3, and label base shape 20. For step 7, start training process. This is the code for start training process. History equal to model.feed. We train _generator step per approach. 5 approach equal to 10. Validation _data equal to the validation generator. And then validation step 5. And then we got the output approach from 1 until 10. Where follow to the step, follow to the number we need as we state in the code. And then for lastly, we need to plot the outcome, where the code start with import matplot library and .pilot splt, meaning that we need to plot the graph. So So for the first picture is training and validation accuracy graph. Follow to the second picture, training and validation loss.
So right now I will proceed to explain the task 2, which is have done the AlexNet pre-trained model. So in this paper, prepare CNN base model, AlexNet has prepared and tried the model with a data set of 20 pictures of object gathered for various vendor, the executive, the
The adjusted AlexNet model is essentially a CNN model, which contains 5 convolutional layers and 2 completely associated layers for the picture discovery by breaking down the similitudes between all adjoining locales. 2 most comparable areas are chosen, and afterward, gathered after recognitions and divisions, the picture of the article to get into the prefix. CNN for acknowledgement and naming purposes. The exactness level is advancing in every age, and approval precision has accomplished around 96 exactness. So this is the image with the multiple recyclable materials that we have done. So that's all from me for task 2. Thank you.
Okay, for the last part, conclusion and recommendation. Okay, I would say that the classification problem can be well addressed by using transfer CNN models. And second, we be able to learn effective features based on the printed model and better performance in recyclable material classification. So for number 3, 3 types of model are a CNN model, train a traditional classification model with handcraft features, and 2 transfer learning model built with pre-trained CNN model, DNSNet and VGG. So for number 4, we combine transfer feature from multiple CNNs could further improve the classification accuracy. And lastly, I would say that DNSNet can be best pre-trained model for image classification and recognition because of its high accuracy.